Let us discuss this example. So we are familiar with the definition of complete matrix space. A matrix space is said to be complete if every Cauchy sequence is convergent. So here we have to prove that C means set of complex number is a complete matrix space with this matrix D of Z1 comma Z2 is equal to mod Z1 minus Z2. So see, we have to prove it is complete matrix space. So I will take one Cauchy sequence, okay, of this set, and we will prove that it is convergent. Let us do that. Let Zn be a Cauchy sequence in matrix space CD. Okay, so where Zn is equal to xn plus iyn for all n belongs to set of natural number. Getting? So you know that every complex number z is expressed as a plus ib. A is called real part, B is called imaginary part. So sequence will be like this: xn plus I yn. Xn and yn. Xn is called real part, yn is called imaginary part. But see, xn and yn both are real numbers. So with the help of real numbers, we form this complex number. So we have it is a Cauchy sequence. We have to prove that it is convergent. So you know that in definition of Cauchy or convergent, we always use epsilon. Let us take epsilon first. Let epsilon greater than 0 be given. So we can use the definition of Cauchy sequence. So therefore, there exists n belongs to set of natural number such that, what will you have, such that d of zn comma zm less than epsilon for all nm greater than or equal to capital N, right? So you know that this metric D is defined in that way. So let us write. So therefore, mod Zn minus Zm less than epsilon for all Nm greater than or equal to capital N. But see, Zn means what? Xn plus Iy. So therefore, mod Xn plus Iy, and Zm means Xm plus Iym. But see, there is minus sign outside, so sign will get changed. Less than epsilon for all nm greater than or equal to capital N. So let us go further. Let us collect real part. After that we will collect imaginary part. So therefore we will have, therefore mod xn minus xm plus I, right, yn minus ym. So less than epsilon for all nm greater than or equal to capital N, right? So you know well how to find mod in complex numbers, okay? So definition is same as norm. So therefore I can write, therefore square of real part, right, plus square of imaginary part less than epsilon for all nm greater than or equal to capital N. So to remove square root, I will take square of both sides. So let us see what will happen. So therefore xn minus xm square plus yn minus ym square less than epsilon square for all nm greater than or equal to capital N. See, we are adding two non-negative terms and we are saying it is less than epsilon square. So 100% each of them is less than epsilon square. So we can write, so therefore xn minus xm square less than epsilon square and yn minus ym square less than epsilon square for all nm greater than or equal to capital N. So you know that what I need to do here, I have to remove squares, okay? So I will take square root of both sides because I am taking positive square root of both sides. Make a screenshot of it first, then we will go further. So by taking positive square root of both sides, we get this step from this step, okay? So let me remove this one, it is not required now. Okay, so it is removed now. See, this is definition of Cauchy sequence, right? So xn and yn both are sequences, okay, in real numbers. So we are getting xn and yn, both of them are Cauchy sequence in R. So I can write, so therefore xn and yn are Cauchy sequence in r. Okay, r du, that means with usual distance, since mod is there. So we have a Cauchy sequence in r, but we know that r du is a complete matrix space. We have already proved it. So see, I will mention, but r du is a complete matrix space. So you know the meaning of complete matrix space. Complete matrix space means every Cauchy sequence is convergent. We are having two Cauchy sequences. So 100% this Cauchy sequence are also convergent in R. So I write, therefore xn and yn are convergent in R. Okay, so therefore they will converge to some real numbers. Okay, so say xn converges to x in R, right, and rdu. Okay, and yn converges to y in rdu. See, after that what will I do? I'm going to use definition of convergent sequence. Epsilon already we have taken, right? So let us use the definition of convergent sequence. So I will write, therefore, for above epsilon greater than 0, there exists n1, n2 belongs to set of natural number such that, see, n1, natural number n1 is for first sequence, natural number n2 is for second sequence. Okay, so we can write such that mod xn minus x less than epsilon for all nm greater than or equal to capital N1, and mod yn minus y less than epsilon for all nm greater than or equal to capital N2, right? A small adjustment I'm going to do, that is, instead of epsilon I will take epsilon by root 2. This is part of adjustment. So let n is equal to maximum of n1 and n2. See, the first inequality was true for n1, second inequality was true for n2, so we need to take maximum of n1 and n2, so we can say both inequalities will be true for this n. Okay, so let us consider. Okay, before that what will I do? Let z is equal to x plus iy. So this is a complex number, get it? So we have x, which is the limit of xn, we have a y, which is the limit of sequence yn. So with the help of this x and y, I have defined a complex number z. So my target is to prove that given sequence zn converges to this z. Okay, given sequence zn converges to this z. With the help of definition of convergent sequence, we are going to prove it. See, for n greater than or equal to capital N, I'm going to consider d of zn z. So you are familiar with the definition of convergent sequence. Okay, what is our target? Our target is to prove that this is less than epsilon, then we can say it is convergent sequence and converges to z. So this is equal to, what can we write? Mod zn minus z, since they have defined this metric d in this way. Let us solve it further, but there is no more space to write, so make a screenshot of it and then we will go further. So let us continue. What will I get? So this is equal to zn means you know xn plus iyn minus z means you know x plus iy. But see, there is minus sign outside, so sign will get changed. Let us collect real part, xn and x. So this is mod xn minus x plus I. I will collect imaginary part, which is yn minus y. Let me remove this one, it is not required now. What will I do? I will use the definition of mod, okay, in C. So you know well how to find mod. It works like a norm. So it's square root of real part xn minus x square plus square of imaginary part yn minus y square, which is less than square root of. Okay, so see, we have already proved mod xn minus x less than epsilon by root 2. But we have to take square, so epsilon square by 2. This one is also epsilon by root 2, but we have to take it square, so it will be epsilon square by 2. So what will happen if you add? So epsilon square by 2 plus epsilon square by 2, epsilon square, so which is epsilon. So we finally proved, so therefore d of Zn comma z, we proved that it is less than epsilon, and this is true for all n greater than or equal to capital N, right? So therefore we say sequence Zn converges to Z. Therefore sequence Zn converges to Z in CD, okay? So but Zn is any arbitrary Cauchy sequence and we proved it is convergent. So that means every Cauchy sequence is convergent in CD. So therefore every Cauchy sequence is convergent in CD. So therefore we can declare CD is a complete metric space. So therefore CD is a complete metric space. In this way we completed this example. Make a screenshot of it. After that we will stop. Thank you. Bye bye.